in this section, we will be looking at solving some more trig equations. So this is going to be similar to what we were doing yesterday. We're just going to look at some new strategies. For this first example, we've got sine x, cosine x minus 1/2 cosine x equals 0. We're solving this for principal values. So we really can't use any trig identities to simplify anything here. What we're going to have to do for this problem is we're going to have to factor out that cosine x that we have with both problems. So we'll have cosine x times sine x minus 1/2. And whenever we do that, now we can set both parts equal to 0. So cosine x equals 0 and sine x minus 1/2 equals 0, which of course just means that sine x equals 1/2. Now we just have to go to our unit circle. At 0, cosine equals 0 right here at pi over 2. So x equals pi over 2, or 90 degrees. That's one of our answers. And then we've got sine of x equals 1/2. So sine is the y-coordinate. That happens right there at pi over 6. So x is going to equal pi over 6, or 30 degrees. So we've got those two answers for this problem. Okay. Example 2 is going to be a little bit different because for example 2, one of the first things that we should notice is that we're looking for 0 less than or equal to x less than 2. So this means that we're not looking for principal values here, but rather restricting our answers to the entire unit circle. So it's going to typically give us a few more answers because we're looking at the whole unit circle here. Now, I see here I've got cosine squared x minus cosine x plus 1 equals sine squared x. So this is going to be a problem because I have that cosine squared x and the sine squared x. So it will be easier if I can change everything to sine or everything to cosine. However, this cosine right here I cannot change because it doesn't have a square. So in this case I want to choose to change everything to cosine. So I'm going to go cosine squared x minus cosine x plus 1 equals 1 minus cosine squared x. And then I want to move everything to one side. So I'll be adding this cosine squared x right here. And I'll be subtracting that 1. So I will get 2 cosine squared x minus cosine x. These ones here will cancel, and that will equal 0. So at this point, I'm able to factor, so I can factor out a cosine since we both have cosines here. So cosine of x times 2 cosine x minus 1 will equal 0. Now let's factor, set each one equal to 0, so cosine x equals 0. Over here, 2 cosine x minus 1 equals 0, so that would give us 2 cosine x equals 1, and then we'll get cosine x equals 1/2 whenever we divide both sides by that 2. So to our unit circle we go. We have cosine x equals 0. Cosine is our x coordinate. That happens right here at pi over 2. Or, in this particular case, also at 3 pi over 2. So because this tells us to look at the entire unit circle, we want to use pi over 2 and 3 pi over 2. We're going to get both of those answers there because cosine equals 0 at both of those places. We also are looking for where cosine x equals 1/2. That's going to happen right here at pi over 3. And also, again, here at 5 pi over 3. And so if we were doing principal values, we would have only given these first two answers, but they told us to look at the entire unit circle, so we have those two extra answers there. Okay. For example 3, we have a similar problem. It is also asking us to look at the entire unit circle, and we've got sine squared x equals sine x. So for this problem, it is tempting on this problem to just divide both sides by sine x. And if you do that, you just get sine x equals 1, and then you would get sine x has a value of 1 at pi over 2. I think that would be our only answer because down here it's negative 1. However, this is not the best way to do this problem because it's going to cause you to lose an answer. So, in general, we do not want to divide by a sine or cosine function unless we're trying to use like a trig identity. We don't want to divide and cancel. So rather than doing this, what we would like to do is do sine squared x minus sine x. Move that sine x over to the left-hand side so that this equals 0. Then you can factor out a sine x. So you got sine x and sine x minus 1. So right here we will get sine x equals 0, and for this one we'll get sine x equals 1. So the sine x equals 1 we have already found doing this problem the wrong way. So that's one of our answers. But there is also the answer where sine x equals 0. This happens at 0, so we would have x equals 0. It also occurs over here at pi, so we would have x equals pi. So we would end up with 3 answers for this. So if you did not move everything to one side, you would lose 2 of these answers here. Okay. For example 4, we've got cosine x tangent x equals negative 1. We cannot break that up because it's not equal to 0. What we can do is use a trig identity here. So cosine x, we can change tangent x to sine x over cosine x equals negative 1. I know I just told you on the last problem not to cancel. You don't want to divide both sides by something to cancel, but if you have a trig identity that's canceling like this, that's okay. So we just get sine x equals negative 1. Sine is our y-coordinate. That y-coordinate equals negative 1 right here at 3 pi over 2. So x would be 3 pi over 2. This one. Okay. For this problem, everything is in terms of sine. What we want to do here is we need to get everything to one side. So we're going to move all the terms over here to the left. And we want to try to factor here. So if we factor this, we could factor it into 2 sine x and 2 sine x, and we could put a plus 1 and a plus 1 there. And that should factor correctly to multiply back to give us 4 sine squared x plus 4 sine x plus 1. So since these are the same, we could just do this once. 2 sine x plus 1 equals 0. So 2 sine x equals negative 1. Divide by that 2. And sine x equals negative 1/2. This problem asks us for principal values of x. So principal values for sine are in the first and the fourth quadrant. We're going to have this sine value right here. We've got that negative 1/2. It looks like it's 11 pi over 6, but because this is principal values, we need to give negative pi over 6 instead. For example 6, we have something to the 4th power, which we really have not seen yet. But when I see sine to the 4th x minus 1, I can break this up into sine squared x minus 1 times sine squared x plus 1. It's the difference of squares here. And then I can set each one of these equal to 0. So I'll get sine squared x equals 1 and sine squared x equals negative 1. To get rid of that square, I need to square root both sides. When I do that here, I will get sine of x equals plus or minus 1. Make sure you don't forget that plus or minus. And so if I look at my unit circle, sine, which is my y coordinate, is going to equal positive 1 right here at pi over 2. And also over here at 3 pi over 2, because that negative 1 is going to also give us an answer here. So 3 pi over 2. And I'm using the entire unit circle, so I'm going to report the values like so. For my other equation, if I square root both sides, I have a problem because I'm going to get the square root of negative 1, which is imaginary, which is not going to be found on the unit circle. So actually, although this is part of the problem, I do not get any answers from that part. And I would just have these two answers right here. Okay, for the next one, we have secant. But it's really going to be best for us to still just factor. We don't want to change this to sine or cosines yet. So we'll have secant x times secant x plus 2. We'll set that equal to 0. So that tells us that we're looking for where secant of x equals 0 or secant of x equals negative 2. So remember that secant is 1 over cosine. So if we're looking at this, this is like 0 over 1. And right here, we're looking at negative 2 over 1. So if secant x is 0 over 1, then cosine of x would equal 1 over 0, which is undefined. And cosine is defined everywhere. It is defined for all real numbers. So this actually does not give us an answer. But right here, if we flip this for that reciprocal identity, cosine is going to equal negative 1/2. And that we certainly have on our unit circle. We're looking at the whole unit circle here. So cosine is our x-coordinate, and we see negative 1/2 right here at 2 pi over 3. So we get x equals 2 pi over 3. And we are also going to get this answer right here, which is 4 pi over 3. Okay, and we have one more example to do here. We've got sine squared x equals 1 minus 2 cosine x. So for this problem, notice that over here I have a cosine, but right here I have sine. And so we really want those two to match. The only way that we can do that is if we turn sine squared x into 1 minus cosine squared x. And then we would like to get everything to one side. I'm going to move everything over here to the right side. So I would subtract that 1, add the cosine squared x. And whenever I do that, the ones will cancel. I will get, we'll write it this way, cosine squared x minus 2 cosine x. And then we can, of course, set each, then we can factor. So we'll have cosine x times cosine x minus 2. And so cosine of x equals 0 and cosine of x equals 2. And so for 0, cosine is going to equal 0 at 0. I'm sorry, at pi over 2. So we'll get x equals pi over 2. And then cosine x never equals 2. So we won't get any answers for that. We'll just have the answer of pi over 2. So please finish up this assignment here for your homework. We'll go over it on Friday if you have any questions.